Welcome everyone.
How are you guys today?
Okay. Come on,
Hey,
jump online.
Sinotando.
I see someone out there in the wild. Who is that?
We can see you, but we can't hear you.
Oh, hi.
Hello.
Hello, welcome.
Thank you.
Welcome Vanita and to Gershom and Arson. To Dalen.
Nokubonga, Bandile,
In the house.
Wenika. Okay, Wenika, I'm going to change your name. In the future, if you guys want to change your name, you can just either like Wenika, say on the group, hey guys, this is my name, and then I'll rename you, or you can see if you guys can rename yourself.
Totally.
But for now, there we go, Wenika. Hello, Sinotando's mother.
Hi, can you see me?
It's nice to see you.
Hello.
It is.
Are you joining us
Okay,
today?
bye, guys. Thank you.
I think we should all put our
Bye-bye.
cameras on. Let's put our cameras on
Sorry?
quickly. Just it's the end of the unit. I'd love to see your lovely faces. Come on.
Oh, okay. Thank you.
Bandile, Wanika, just quickly turn you won't, yeah. I just want to see your faces chop. Be brave. There we go. Hello. It's so lovely to see to see your faces. Okay. Who else is on? Komogelo, Michael, welcome. Just pop your camera on for a second, just so we can see your faces. And then those who are ready to roll, there should be 2 questions on the screen.
Bandile says he's still eating.
I was eating just before this. I'm still drinking my tea. Look. Okay. All right. Yeah, so welcome to everyone. And while we wait maybe another minute, if you could just get started with this question. The unit we're finishing today is on this famous theorem called Pythagoras. And so if you're feeling if it's your first time, you may feel a little bit confused. We will try our best to catch you up though. Okay. Maybe somebody wants to jump online and give us a little summary about what Pythagoras' theorem is, or maybe you can just shout it out. Like, what do you remember from previous lessons? What was the most important idea? You can put it in the chat. Azan will give you a shout out, or you can speak it out loud.
The theorem of Pythagoras states that the hypotenuse is equal to the sum of the squares of the other two shorter sides.
You're super close. You super thing. So you told me that the hypotenuse, which is the side opposite the right angle, is involved, but it's not just the hypotenuse. It's the square of the hypotenuse is equal to the square of the sum of the other 2 sides squared. So that is, but you get 1,000,000 points for just being so brave and jumping on and getting it like 95% right. So, well, who was that?
Oh, one day.
Well done. And showing everyone it's not so scary getting up and being in, Okay, Alzan, do you have anything before we get going?
Nothing from the start, Peter. I'll just hop on again to say thank you to all the learners. But otherwise, enjoy, guys. And yeah, ask as many questions as you need to, for this last class.
Yeah. And any problems with your IT stuff or whatever, Alzan is in the background the whole time. And so she'll help you out.
Sure.
Okay, so what I'm going to do now is, if I can, I don't know, I've managed to draw something and I can't seem to get rid of it. Let's see if I move the screen down. Let's see. Can you all see the question? What have I done here? Cut. Nope, wrong thing. Okay, give me a second. I'm just going to move everything down. Go to text mode. Okay, let's do this. Okay, so what I'm going to do is I'm going to, this thing is just won't go away. Flip. Let's get Sorry, guys, having a few technical glitches here. Can this go away? Nope. Okay, let's do it like this then. Then we can just leave that a little bit there. Okay, so I'm going to call this question number 1, and I'm going to call this, actually, now that it's gone away. Sorry, my pedantic side wants this to be question 1, and it wants this question 2, because, yeah. Okay, question 1, question 2. Now, you'll notice that these are multiple choice questions. And the thing that we learned in previous lessons was if we take the hypotenuse and we square it, so for example, c squared, it should be equal to 24 squared plus 7 squared. And what we need to do is we acknowledge the reason we've used, and that gives us Pythagoras, but that doesn't give us the answer. We still need to get c equals to something. So it could be that, or it could be that. Now, what I want you to do is I want you to try and work out the answer for both of the first two, and then you are going to launch, I'm going to send you a poll now, and then you are going to answer on that poll if all goes well. So let's see if I can find that poll somewhere, wherever it's hiding. And then you are going to answer this question. So let's see, it's activated, I've done that, and done that. Where's it gone? Let's minimize this. Sometimes, oh, there it is. Launch. Okay, give me a thumbs up if the poll is on your screen. Just give me a thumbs up, and then I'm going to give you a chance to lock in your answers for the first two. Okay, I see some thumbs up, so I think it is working. And then I want you to try and get the answer for the first one, and then try and get the answer for the second one. And that's just checking the basics of Pythagoras, using this theorem to solve for unknown sides. And if you need, you have a calculator nearby. So some numbers that could be helpful if you don't have a calculator. I suppose 24 squared might be helpful to know. So 24 squared is 576. 7 squared is 49. I already know that. 11 squared is 121. And 16 squared is 256. So I'm just putting those there just to help you. But I want you to try and answer the question. If you are feeling horribly confused, I will pick that up now when we answer the poll, and I will go through everything in absolute detail. But I just want to see how many of you can do this at the beginning. Okay, so if you can put your microphones on mute, I should have said at the beginning. So unmute yourself when you talk, but if you can leave yourself on mute most of the time, that does work quite well. Okay.
Peter, we've got Bandile who asked if you can maybe just scroll down a bit for the next question.
I can scroll. Yep, I can. So let me see if, oh, too much. Do you want it to be bigger? Is that the request? Let's have a look. Does that help?
No, we're unable to see the options for the second one.
Ah, I see what you mean. Like that.
Peter, nothing's happening on my side.
Okay.
Hello.
Let me.
Nothing's happening, sir.
So let's try this again then. Let's try this again. Apologies, but that's why having good communication is important. That's desktop. Okay, how about now? Is it much better now?
Yes,
Yes.
sir.
That's great.
And see, this is the importance of good communication, guys, in all relationships. You got to do it. Okay.
Hello,
Hello.
how are you?
I'm good. How are you?
I'm also fine.
How is it going so far with the opening question? Do you remember seeing this in class, or is this the first time you've seen this?
I remember seeing this in class.
In class, okay. So I always find writing out the relationship first is quite a good idea, just to get me going. So we'll say c squared is 7 squared plus 24 squared. Give a reason. But now we might need to use our calculators to get a value for this bit over here. Let me use a different color. Marker. So we need to find a value for all this stuff. And I'm not ashamed to use my calculator for this one. So plus 7 squared, and I get 625. Change that back to this. But now I don't want c squared, I want c. So what do I need to do to get c by itself? Who has any ideas?
Square root.
Yes, indeed, I must square it. But the one important thing is the golden rule of equations is I must do the same thing to both sides if I square root. So I am going to square root, and then I'm going to get c is the square root of 625. Now that isn't one of the answers here. So it may be that if I put that into my calculator,
Your
Can you
square root
found?
is 25.
which means is one of the answers. So one of the answers is B.
C is
Okay.
equals
And 8 of you, or a lot of you, most of you chose that. So it looks like the first one went well.
C is equals to 25.
It is equal to 25. Absolutely. Well done, everyone. Happy smiley face for you guys. Let's try and do number 2. Number 2 is a little bit harder because we're no longer looking at the number on the hypotenuse. It's one of the other sides. And so what I would say is, again, we write this out, but I always go 16 squared equals a squared plus 11 squared. And now we need to move things around. In fact, tell you what, let me send you, put your votes in, and I'm going to end the poll now, and then I'll finish this question. But I want you to get the results back live. So I'm going to end the poll, and hopefully you guys can then see the answers to that. Are you seeing the results of the poll? No, you're not yet, huh? What did I do?
Are you gonna end the call, and then when you come back, we should be already having the answer?
Yeah, wait, let me share the results. Yes, yeah. But now I'm going to give you the answer in a moment. I'm just trying to see, I'm almost testing out this poll thing, which is new. It's like a new tool, my new like toy for the day. Okay. It makes it easier to communicate with the students. So this next one, 16 squared was 256, huh? And this was 121. Okay, I'm a bit stuck now because I want to get A by itself, but A is sitting over here. So I need some suggestions. What do I need to do? Who would like to give me a suggestion or an idea? You can put it in the text, or you can put it anywhere you like.
Move A to You move A to the left.
You move the A to the left. You could move the A to the left, but normally when we solve an equation, we try to get the variable by itself. And I think that the thing that's causing trouble is this 121. Would you guys agree with me on that?
Yes.
So if I want to get rid of the, let me get rid of the other stuff. I'll make this a bit bigger. If I want to get rid of, not get rid of it, if I want to move this around, what's the opposite of adding 121?
Minus 21.
Minus 121. So what I'm going to do is I'm going to take away, let me just get some blue. I'm going to take away 121 on this side, and I'm going to take away 121 on this side. Now, we say that's using the inverse when we're solving this. So let's go 256 minus 121, and we get, let me just make sure that's right, 135. And then this is going to be 0. And so we get my a squared by itself. Now, can you see how it's a lot easier to deal with there? Now, the final step, which of the 4 answers do you think is going to be the answer here? I suppose you guys have voted already, but is it clear which one's going to be?
B.
C.
Okay, well, B would be the square root of 35, but I've got 135 here. So if you think about it, shouldn't I square root both sides?
C.
It's going to be C, yeah. Because when I square root both sides, I get 135 square rooted is equal to A. And so that's going to be the correct answer.
Peter, I'm so sorry to interrupt you.
No, it's fine.
We just need to start the live stream, please.
Oh, is there a live stream? Sorry.
Yeah, there is a live stream, but
Yes,
it
it's
hasn't
not started.
started.
Okay.
So the live stream audience is asking where the live stream
Oh,
is.
sorry. No worries. Okay, let me do that. Obviously, because I'm running polls, let's have a look.
So sorry to interrupt you. If you just go to more, and
More.
it should pop up there in the corner. Next
And
to
live on custom live streaming service?
live on custom live streaming
Yes.
service, yes.
Apologies, we did actually talk about this before.
No, it's okay. I thought I was on.
Okay, no, it's because we're toggling between the host and the co-host and all that stuff.
No, it's fine.
But we'll get it figured out. But we've just done the do now question, so we're ready to rock and roll now.
Okay, cool. So is it on, Peter? Sorry.
It does look like it's on to me. It's saying preparing live stream. And preparing live stream. Let's have a look. There we go. Let's move to a next question. It says it's still preparing live stream. It might take some
I can't write in message, so I can't.
Okay, guys, while we wait for the live stream, I'm going to give you an exam question from an old exam that I set, I think, back in the day. And so I want you to try and do this question. It's got 3 parts, and I want you to get started with that now. Okay, can everyone see the screen? It looks a bit like a house. Okay, so you get started with that, and then I will just see that the live stream is what it's doing there. So, Marilise, I think it is preparing, but I'm not sure if it's hanging because of the, it says stop. I can say stop live stream, but it's giving me like a thing that says preparing live stream. But if that makes sense.
Just keep it there. I think we need to do something else on the back end. I'll be back shortly. Okay. Thanks so much.
Maybe Marlies,
Yes.
I just want to know, Peter, are you doing any polls again for the rest of this?
No. So actually, I can make you.
Maybe you can make me a host, then I'll try from my side again.
Perfect. I think that might make it easier because there's something going on with the host functionality that. Oh, I think one of my polls was still open, maybe. So I think I had to close it.
That shouldn't really make a difference. It might be something else. So I'll be back just now.
Oh, it is unable to live stream, yeah. Okay, Alzan, you've got the host. You can look into that. I'm going to continue with the lesson part.
Awesome. It shows that it is live streaming.
Perfect. Perfect. Sorry about sorry to my our class on the internet. If you're just joining us, we just did a do now question, but you didn't miss too much. And we're trying to do this exam question over here. And so if you could start by asking, not all of them are Pythagoras questions, but Pythagoras is definitely involved and it's worth 4 marks. So we'll see how you can do with this. So first of all, we want to find where is AE on the drawing. AE is going to be over here. Where is FC? FC is over there. And BC is going to be
the same.
okay.
BC.
So this is a handy trick that I often recommend to students with geometries. It's often helpful to color code what you're dealing with. So the first thing to realize is because this is a rectangle, this is going to be 50 millimeters.
Yeah.
So that's 50. FC is opposite 8 centimeters, but it cuts it in half. And so this is going to have to be 4 centimeters. So if this is 4, and now this one over here, let's just make sure we've got this right. Calculate the length of BC. So we know that this will be 4. Now, the one ambiguous part here in the question is whether or not the 3 refers to this over here or the 3 refers to this over here. Now, because the hypotenuse has to be the longest side in the triangle, the 3 actually has to be the line that's going up like this. So this is 3, which means that, okay, so let me write the answers in first. So FC was 4 centimeters. And then BC, well, using Pythagoras, we can say that BC squared is 3 squared plus 4 squared. If Pythag, and then BC squared is 9 plus 16, which is 25. And then if I square root both sides, I get BC is 5 centimeters. Okay. Now, that's a very famous thing called a Pythagorean triple. Guys, if you could just put your microphones on mute. There's a bit of background feedback coming through from one of you, and it probably will be helpful to put it on mute. Okay, let's move on to the next question. It's another multiple choice one, but you're going to have to work it out, and then you're going to vote for me in the chat. So, what is the length of side X? I'm going to go quiet. The only hint I'm going to give you is that there are right angle triangles involved. And so you know quite a lot about right angle triangles, but I'm going to give you, it's now 23 minutes past. I'm going to give you until 26 minutes past. Have your calculator handy, and then we'll come back in a moment. Okay. If you're on the internet and you've just joined us, because I saw a live stream thing, we're doing a question on using the theorem of Pythagoras, and the goal is to find the length of side X, and you're given these 2 right angle triangles. And the building blocks of Pythagoras, often it's just written like this, where A is the hypotenuse or the side opposite the right angle. And whenever we use this theorem, we give the reason Pythag with a dot to acknowledge how we know this relationship exists. Otherwise, it's like we're pulling out this relationship out of who knows where, and we have to say we're referring to the specific bit of knowledge that's been proven. Okay. Okay. So for those who are feeling a little bit under pressure, I'll give you another hint. This hint is that you need to build a bridge. That's my cryptic hint. So how does that bridge help you to get? So if I wanted to find the bridge, I suppose I could give it a name. It's often easier if you give things letter names. So since I've called it a bridge, let me call it the letter B. I didn't have to use B, but although actually given that 6 and 8 look quite similar to B, that's confusing. So let me call that C. So C squared equals 6 squared plus 8 squared by the theorem of Pythagoras. And this is where I can actually use my calculator and just go, look, I know I could work out the individual squares, but I can just go 6 and 8 squared, and I get 100. And then if I square root both sides, I get C is 10.
Bless.
I now know that this is 10. But I now still need to find this X over here. Okay, I see lots of answers are coming in for C. So let me speed it up a little bit. So if I now go, I need to make sure I know where my hypotenuse is. So the hypotenuse is up here, and I go 12 squared equals 10 squared plus X squared. And I'll put my reason. And 144 equals 100 plus X squared. And now what we're going to do is we're going to do that trick where we get rid of the 100. And the way we're going to do that is we're going to take away 100 from both sides. And then we have an X squared in the corner. Let me scroll a little bit. So that goes away. Then I get 44 is equal to X squared. And then if I square root that, the square root of 44, okay, this is where your calculator comes in handy. I'm going to be going a little bit quickly here. I'm going to do this. And when I do that, I'm doing the same thing to both sides. And my final answer is going to be the square root of 44 is equal to X. Now, the problem is there is no such answer here, but one of them is equivalent to this. Now, what I could do, and this is some of a section called surd, so you don't need to know this yet. You can just put this into your calculator and your calculator will show you that this answer is the one. But basically, 4 times 11, that is the same as, in fact, I'm not even going to go into it. That's a grade 9 and grade 10 problem. So the answer is C, so that's great. Okay, well done, everyone. So I want you, this is going to be a quick speed test, okay? So get your calculators, get your everything else. You are going to do, you have got a minute and a half a question. And so minute and a half, 3, 4.5, 6. Actually, no, that's even, let's make it 6 minutes. You've got 6 minutes to do these 6 questions. And so I will give you the answer in 6 minutes. And each of these you need to find. And I want to see if you can get more efficient in doing this. And whilst you're doing it, if there are some of you who are feeling very lost, what I want you to do, well, not even if you're feeling very lost, if you just like a little bit more help, say you're getting stuck, I'd love for you to ask a question. So some of us are working on this in the background. You can either ask it in the chat or you can pop and ask it with your voice. But if I don't hear from you, I'm going to assume that you're busy working. Okay.
Well, I am lost, so
okay.
I don't understand how to calculate this.
Okay. So I'm going to do this first one, A over here. Can you see that 2 of the sides, the one side is 3.4 and the other side is 9? Okay. And then there's another side.
Problem, I think it's not.
Huh?
I'm thinking it's network.
Okay. Can you see what?
It's network. So like, yeah, like kind of.
Oh,
I can't hear you properly.
Okay. Could be the network.
Okay.
What side of the triangle is the A? in terms of names, what special name do we give to that side? A?
I think it's
Hypotenuse.
It's called the hypotenuse, yes, sir? And so what we're going to do for this first one is we're going to say that a squared is equal to 3.4 in a bracket squared plus 9 squared. And the reason is still Pythagoras. Now you need to do some more work after that, but that's the first step because it's saying the square on this side plus the square, okay, I know it doesn't look like a square, but use your imagination, is equal to the square over here. Now the green thing should be a lot bigger, but that's the basic idea. So once you have done that, you need to still then do some working out that goes with it. Let me enlarge my screen. So we said that a squared is equal to 3.4 squared plus 9 squared. I need an answer for what 3.4 squared plus 9 squared is. So I'm going to go to my calculator and wait, 3.4 squared plus 9 squared.
92,56, I think.
Perfect. Yep. And then if I square root both sides, the reason I do this is if something is equal and I do the same thing to both sides, it still has to be equal. And when I do this, I get a, and so the square root of 92.56 is going to
9,62.
Perfect. Winning at life. So we've done A. So A is taken care of. Now, I will also do B with you, and then you'll fly a little bit more solo in the other ones. So in B, the key thing is the hypotenuse is given to you. So in this case, you go 17 squared is equal to B squared plus 8 squared. And then the reason is just, again, get a bit sick of writing that thing. Okay, now what some people sometimes start to do is they start to recognize a pattern and they go, I know I'm going to have to get rid of this a squared. Okay, now if I want to get rid of it, I'm going to have to do the same thing to both sides. So I know I need to take away 8 squared from both sides, or if you feel more comfortable, you can just write 8 squared as 64. But both are correct. But what I'm going to do is I'm just going to say, look, I know I need to take away 8 squared on this side. And then on this side, I'm also going to take away 8 squared on this side. And then I need a number for that. What is 17 squared minus 8 squared? Can someone help me?
222.
222? I get 225? You get 225?
225.
Yeah. Okay. Now that goes away, so I get b squared,
Oh.
and then I square root both sides, and I think I will get 15. 15?
Yes,
Do you get 15?
Yes,
And
sir.
so the units were centimeters.
Centimeters.
Yeah. So what I want you to do is we've done this one and we've done this one, and I'm going to let you have a bit more time for the next 4 so that you can get some more practice. You stretch. Ugh. I think I'm used to standing up when I'm teaching, so every now and again I have to have a stretch. Okay, what about this one here? Let's make it. So that's 10 squared Okay, so you should get 8 as your answer for C. Can you just give me a thumbs up if you got 8 for C? Thumbs up if you got an 8 for C. 8 for C. Okay, fantastic. Okay. Okay, I'm gonna give you about another minute or so, and then I'm gonna start writing out the answers for the other ones. So this is the d squared equals 1.9 squared plus 2.4 squared. Oh, this is too thick. Pythag. And then I need my calculator. Plus 2.4 squared. I get d squared is 9.37. And then if I square root both sides, I should get 3.06 centimeters. Okay, I just want to see, before I do the last two, do you guys spot any patterns? Because sometimes you'll notice we've done quite a few of them now. And are there any shortcuts that we could use that would speed this process up? Has anybody noticed any patterns or anything they want to draw our attention to? Is there anything that we're always doing or repeating, or maybe we could use less steps in this process? Any ideas? I mean, it's fine to do it like this, and we're getting it right, but I'm just wondering if there's any way to make it a bit easier. Are there any ideas? Just going to get rid of some of the working here. Apologies while I just scrub out some of the stuff. Okay, so if there are no obvious reasons to make it, quicker or easier, then I'm just going to use this method for the last two as well. So I'm going to say for E, it's 15 squared equals 9 squared plus E squared. And we're just going to say my reason. Now, what I was thinking of is that whenever we're not solving for the hypotenuse, it feels a little bit like maybe this next step I could skip out. And I could say, I know I'm taking away 9 squared from both sides. And what happens is I could maybe jump straight to that step. So give me a thumbs up if you understand what I did to get to this next step. Give me a thumbs down if you're like, I don't understand how you went from this line to this line. So thumbs up if you understand what I did. Thumbs down if you feel like, I don't know what happened there. Okay, I see 1 or 2 thumbs. Show me your thumbs. Is this like magic? Okay, so all I did, and I would recommend putting in the extra step, is that I took away 9 squared on this side, and I took away 9 squared on this side. And these ones knock each other out. And so all you're left with is this bit here. And it's just a way sometimes that you can speed things up, but you do not have to use it. If I go 15 squared minus 9 squared, I get 144. And now I know that I always square root both sides. Whenever I get to this last step, whenever I'm left with a square and I want to get just E, or just a variable, and then I should get 12. So E is 12. And then the final one, which is F, is going to be as follows. So feel like I'm playing the keyboard here with all the hotkeys. Okay, 20 squared equals 16 squared plus f squared. Now, I want to point something out. Notice how I always check which is the hypotenuse, and I write that first. That's a really important step, because if you don't write the hypotenuse as the one by itself, the relationship doesn't hold. Now, the next thing I'm going to do is I'm going to deal with the 16 squared here. The 16 squared is stopping the f from being by itself. And so I'm taking away 16 squareds from both sides. And the way I would do that is I would just say 20 squared minus 16 squared equals 16 squared minus 16 squared. I feel like I'm coloring in, but I'm just trying to show you how I'm doing the same thing on both sides. Now this side is nothing. And so I need a number for 20 squared minus 16 squared, which is 144 equals f squared. And to be honest, I think that's the same. When I square root that, I'm going to get 12. So f is 12. Okay. Are there any questions or comments before I move on? Anything you want to let us know? How are you feeling out there? Are you feeling like there's hope here? Or are you feeling like, oh my goodness, give me an emoji or something. Give us an emoji. How are you guys feeling after that? I'm sure you want to express yourself, guys. Come on. I can't actually see the chat, but wait. Oh no, I see a I see a thumb, I see a fire, I see a confused face, I see a clap. Thank you, Ozan. Yes, okay. Well, let's keep rolling. Okay, I'm taking it up, not taking it up a notch, but for bonus points, what type of shape is this? Oh, flip, I give it away in the question. So what type? It's a trapezium. Now, how am I gonna use the theorem of Pythagoras to find the value of k in this question? So I actually want some suggestions. I'm not going to move on until I get suggestions from the class, because I've been dealing with triangles up to now, right angle triangles. And now all of a sudden I'm throwing what's called a trapezium at you. How am I meant to use the theorem of Pythagoras with that? Has this maths teacher gone mad, or is there hope? What are your suggestions? Anybody? How are we going to use the theorem of Pythagoras for this shape? Are there any suggestions? I'm confused. Don't worry, it's not a problem. Okay, here's the sneaky thing. It turns out that triangles are inside of all sorts of other shapes. So if I draw what's called a perpendicular line down like this, this is now a right-angled triangle. Okay, now if I look at this shape at the moment, okay, now this is actually quite a sneaky one. Is this? Let's have a look here. 30, that's 22. Now, how long is this guy? Fine, okay.
With the red line, 20 then.
Ah, yes, well done. Who was that?
Alwande.
Alwande, you have spotted it. You have solved the missing link in this problem. So how did you know that was 20?
In a rectangle, opposite sides equal.
Perfect. Okay. Now, on our journey, do you have an idea of where we could go to next? We can't solve for k yet, can we? We don't have enough information. And that's the whole point of the question, is to find k. But what could we maybe find?
I think we should find the side from there, yeah. From there to the other point. Yeah.
Are you talking, am I tracing the line that you're talking about?
Yes.
Okay, because we can use the theorem of Pythagoras. So what we're going to do now is I'm going to say, what is the hypotenuse? The hypotenuse is this one up here. So I'm going to say 22 squared is equal to 20 squared. Now I don't know what this value is, so I'm just going to make it an A because it seems easy enough, plus A squared. And the reason I know that this relationship exists is because the theorem has been proven for all right-angled triangles. Okay, now I'm going to take away the thing that's causing me stress is this 20 squared, because I'd love for the A to be by itself. We say in maths, we want to isolate the variable. We want A to be all by itself. So what I'm going to do is I'm taking away 20 squared from both sides. And I am then going to get, oh, that's too thick. What's going on here? Oopsie daisy. Sorry, guys. This is like a multicolored extravaganza. I get, basically, if I take away 20 squared from both sides, I'm going to get this over here, and this is going to get knocked out. And all I need to do then is I need to get a value for that. Can someone help me? What's 22 squared minus 20 squared?
$84.
84. Okay, fantastic. And what do I get if I square root 84? Can you give me a decimal?
9.17.
So 9.17. Did anybody else get that?
Yes, sir.
Fantastic. Okay, now we're almost there. We got 9.17 for that. Now, what I would really like to know is if that's 30 and the green bit is 9.17, how long is this bit over here going to be? Could we work that out?
Subtract 30 from 9.2.
So we're going to go 30 minus 9.17, and we get 30 minus 9.17. I get
20,83.
Perfect. Now, what do we know? What else is special about 20,83? Well, going back to the beginning, isn't 20,83 going to be equal to K because it's a rectangle?
Opposite sides equal.
Yes. So using the same
Side.
idea that you used earlier, we're just going to say, well, what's opposite here? This is going to be 20.83 as well. Now, this is considered a hard exam question for Pythagoras. And the main idea that I want to introduce is that we looked for, we made our own right angle triangle in the shape. And so that's the key thing that I want you to walk away with. Okay. And if you can understand that, you're doing very, very well. Okay. Now, what I want to do is I want to end this section with a quiz. Okay. So, in fact, actually, one more thing, and then we're going to end with a quiz. If I said to you, so I just want to end with something called the converse of Pythagoras. Has anybody, give me a thumbs up if you've heard of the converse of Pythagoras, and give me a thumbs down if you've never heard of the converse of Pythagoras. So thumbs up if you've heard of the converse, thumbs down if you've never heard of it. Okay. All the converse of Pythagoras says is it says, normally you are given a right angle triangle and you can use the relationship. In this particular scenario, you have not been given a right angle triangle. You've just been given a triangle with sides. And in a triangle, there's always going to be, well, depending on if it's isosceles or not, there's always going to be a longest side. So I'm going to call this side L. There's going to be a middle side, which I'm going to call M. And there's a shorter side called S. And if I have to look at this question over here, I'll call this L. Well, let me even draw it without a cursive. I'm going to call this L. I'm going to call this M. and I'm going to call this S. And all that the converse theorem of Pythagoras does is it helps us check whether or not a triangle is in fact right angled. What do you think I need to do to check whether or not it's right angled? I'd love for someone to tell me what to do. How can I use the converse theorem of Pythagoras to check if the way we write it is like that?
We check if
PQ
squared plus QR squared is equal to PR squared. Yeah.
So all I do is I take the longest side, right? The longest side will always be opposite the biggest angle. So in this question over here, the longest side is 25, and I get a value for 25 squared. And then what I do is I take the other two sides, 7 squared plus 24 squared, and I see what I get for them. So let's see what happens here. What is 25 squared? Can someone help me with that?
625.
Okay. And then what is 7 squared plus 24 squared?
625.
This is good news because this relationship holds, we know therefore angle Q is 90 degrees by the converse theorem of Pythagoras. Okay. And the 90-degree angle will always be opposite the longest side. Now, what I want you to do is I want you to check this other one. I want you to check whether or not you think 2.2 is a right angle triangle. And I want to give you 2 minutes to do that. So try and use the method that I showed you. Look at what's the longest side and check. Do you think 2.2 is a right angled? If it is, once you've checked, put a thumbs up in the chat. If you don't think it is, put a thumbs down. All right. So what did I do? I started with the longest side, which is 15.7. And so I'm going to square that. And I also need to find how much 8.5 squared plus 13.2 squared adds up to. And so I'm going to need my calculator, I think. So remember, once you've got the answer, thumbs up if you think it is right angle, thumbs down if you think it isn't. And I want you to make your vote. Like I made my vote yesterday in voting day. Okay, let me use a different color. So I get 246.49 here, 8.5 squared plus 13.2 squared. I get 246.49. And because they're equal to each other, therefore angle I will equal 90 degrees by converse Pythag. Okay, so the converse theorem, it doesn't get as much attention as the normal theorem, but it basically allows you to check whether or not a triangle is right angled by checking for that relationship. Whereas normal Pythagoras says, here is a right angled triangle, you can just use these relationships. So it's a slightly different idea. Okay, we're not going to have time to do the full exit ticket. So what I'm going to ask you to do is we're actually going to finish off the lesson now with a little bit of a chat and just a reflection. But straight after this lesson, I would love it if you guys would do this little quiz, because I think it'll give you good feedback. It'll also allow me as the teacher to see, okay, how much you've understood, how much you haven't. And so I'm not going to start it now, but I'm just going to ask you to write down that code. And if you're new to this, you go to joinmyquiz.com and you'll see everybody else after the lesson will be playing. So you'll see the names come up in the game that you're playing. So it's not like you'll be playing with all your other classmates in the lesson. And then also just to let you know that next week, Monday, we'll be starting a new unit on area, perimeter, and volume and units. So that's going to be the next lesson. And then after that, we'll be doing sessions on exam preparation. Okay, so that's the future units. You can see that on the Watobe website, all details. And do tell your friends. I know I'm in touch with many students at school, and many of them are feeling stressed about exams, and they just want a place to go to get some help or maybe brush up on something. And so you can help your friends by sharing the word. Okay, Alzan, I'm pretty much ready for you to come back in, and then we can finish off with a bit of a chat and taking questions from the students as we need to.
Okay, can I please ask?
Yes, please go ahead.
How do you do the LCM? How do you find the lowest common factor and the highest common factor? Okay.
Can I suggest you go to the Watobe website? There's a grade 8 playlist. So in the time that we have left today, the LCM and the highest common factor, that's an idea that is important, but you'll probably find that in another video. Whereas if I start now with that, there's not going to be time. So do you know how to go to the YouTube channel, and you'll see grade 8 playlist, and then you search for the topics, and that will be with numbers and factors and all those things. Okay. The YouTube channel is very cool. Okay. Any other questions? Okay, then I'm going to stop sharing my screen, and then just write down the code. Was there another question? Okay. I'm going to stop sharing my screen, and Alzan, back to you. But that was good, guys. Thanks for your participation. It felt cool to be on the side, and I hope that it was helpful. Okay, Alzan, over to you.
Awesome. Okay, now you guys can hear me.
Perfect.
Okay, guys, well done. So as you can see here, you've completed 4 lessons. Today was just revising everything and revision and exploration. And I brought this little dinosaur back. I'm not sure if you guys can remember him from last time as well, but this is just to say congratulations. Thank you for participating. Thank you for being here. Thank you for being brave to ask questions and to put yourself out there. We really appreciate it, and we hope to see you guys bear the fruit of getting good marks from all the hard work you guys put in. So well done to you all. You can give yourselves a hand clap. Good job. Awesome.
Proactive students.
And then I'm sure you guys would like to see the leaderboard. Is there anyone that would like to see the leaderboard?
Yes, I want to see who's been practicing.
I wonder. Okay, so Peter would like to see the leaderboard. What about the other learners?
Let's have a look.
I'm not so sure. Okay, we've got Wainika.
Lutando's keen. Lutando's keen to see the leaderboard.
Awesome. Okay. Are you guys ready? Put your hands together because this is a good one. Okay, here we go. We've got Awande with 11 activities done on the Watobe app. So good job. That's great work. Well deserved to be first place. In second place, we've got Wainika. Well done. You've got 8 lessons done on the Watobe app. And then thirdly, we've got Bandile, Gershom, and Fumuzile, who has a tie with 3 lessons done. So well done to you all. and then, Peter?
We'll be looking at, so after this, the quiz that I set you, I'm going to be looking at that, and we can, I will be super keen to see how you guys do in that quiz and just to see who's participating. So please give that a go.
Yes, of course. Okay, so it's not done yet. You guys can still go into that quiz, go and finish it up, go and test your understanding on this topic. And then we'll still see you guys on Monday just for the next topic, like Peter said. We'll be dealing on measurements, if I'm correct.
Yeah, and so area, perimeter, and volume measurement is the topic,
Awesome. Okay, guys, so that's all from our side. If you have anything else to say, please feel free to say so. Otherwise, you're more than welcome to leave until we see you again on Monday.
Yeah, and thanks to everyone. It was, I think every time I do this, each unit is a little bit more familiar, and I hope it's the same for you. I hope that you're getting used to the environment and finding what works. And don't be afraid to speak up and say, like, look, this works, this doesn't. We do, that's the only way we're going to learn together. But I feel like I'm settling into this, becoming more normal. Yeah.
Especially with the polls.
Yeah, I love them. Okay, cheers everyone.
Awesome, guys. Thank you.
Bye,
Bye-bye.
everyone.
Take care.
Cheers, Bandile. Bye, Monica. Bye, Gershon.
Bye.
Bye, Songre. Bye, Michael. Bye, Alwande. Bye, Arson. Well, oh, there's lots of Intando, Michael. Look at all the people.
Ayabonga, Bandile.
Well done, guys, for being hardworking students.
Yes.
Okay. All right.
Awesome.
I'm gonna go for a run.